Welcome to Volume by Shells about an alternative axis. So again, the idea here is sometimes we will rotate around a horizontal or vertical line that is not the X or Y axis. So sometimes we will rotate about a horizontal or vertical line that is not the X or Y axis. And all that does is it changes our radius computation. So all it changes is the radius computation. And so we just subtract off essentially the axis. So for example, let's go ahead and find the volume of the rotational solid formed by rotating the below shaded region about the vertical line x equals -1. So the shaded region we are working with is the region above the x-axis below y equals sine of x. Just that first region, so looking from x equals 0 to x equals pi. So we are going to be rotating around the line x equals -1. So if we wanted to focus on a shell, essentially the shells that we are looking at, we take a vertical cross section and we rotate that vertical cross section of our region. We rotate that vertical cross section around x equals -1. And then we give it slight thickness dx. So once again, our thickness is dx. Our radius, we're looking from x equals -1 to our x value. And so we have our r of x is just x minus -1, otherwise known as x plus 1. The height we are looking at, the cylinder height, we are running from the x-axis to y equals sine x. And so we have our h of x is just sine of x minus 0, or h of x is simply sine of x. So from here, putting this all together, we have our volume is, we are going to run from our bounds of 0 to pi, since we're looking in x's. Oh, sorry, I forgot my dv. Let's do dv first. So putting these together, we have our dv is 2 pi times our radius, r of x, times our height, h of x, times our thickness, dx. Again, we're essentially just taking the surface area of the sides of our cylinder and giving it a little thickness. So we are looking at 2 pi times x plus 1 times sine of x dx. Putting this all together, our volume, we have V is equal to, we are looking at the definite integral from 0 to pi was what our x values ran through, of 2 pi times x plus 1 times sine of x dx. So this becomes 2 pi times the integral from 0 to pi of x sine of x plus sine of x dx. Once again, we have a little integration by parts going on. So that x sine of x we would take a u to be x, our dv to be sine of x. X will go to 1 and then 0. Integrating sine, we go to a negative cosine of x, followed by a negative sine of x. We will add on the first product, diagonal product, subtract off the second, and then we're just adding on an interval of 0 at the bottom. So we are looking at putting this all together. We have 2 pi times that first component becomes a negative x cosine of x plus sine of x. So that is our integration by parts. Then the sine of x just integrates to a negative cosine of x. We have minus cosine of x. We are evaluating at 0 and pi. So this becomes 2 pi times, we have a negative pi times cosine of pi plus sine of pi minus cosine of pi. Then we are subtracting off. We have a 0 plus sine of 0 minus a cosine of 0. Again, that whole thing is being multiplied by the 2 pi out front. Cosine of pi is -1. Sine of pi is 0. Again, cosine of pi is -1. Sine of 0 is 0. Cosine of 0 is 1. So we are looking at 2 pi times, in brackets, negative pi times -1 is pi. And we have plus 0 minus a -1 becomes plus 1. Then we are subtracting off a -1. So we become another plus 1. Let me update my screen quickly. 2 pi times pi plus 1 plus 1. Or in other words, 2 pi squared plus 4 pi. So this is our volume. Again, note, we could have used washers. But our inner and outer radius would have involved sine inverse. Sine inverse of x in order to put our radii in terms of x. Sine inverse of y in order to put our radii in terms of y. And then, so our integrals would have involved a sine inverse squared. So I find in this case, shells to be easier. So it's really sort of a problem by problem situation, just in terms of which functions are easier to work with, the function or its inverse. So in the next video, we will just do a quick summary of the different methods we've used and kind of when each one makes sense.